Okay, this is from last night, 7B. Is f of x equals 5 divided by the cube root of 2x minus x squared. John.
Oh man.
Can you convert that into the fraction into a yeah, try that square root and all that stuff, simplify that so you can switch that.
Oh, that's gonna be.
I'm always so eager.
I am.
Especially because we talked about this yesterday too, right?
Yeah, that's gonna turn into a negative 3. No, that's not the negative. 1/3. Negative 1/3.
Good.
Yes.
Okay. So it turns to this: 2x minus x squared to the negative 1/3. Very good, John. Okay. So okay, let's go through how we get that in 2 steps. Number 1, a negative exponent means 1 over, right? So the 1 over brings to the denominator. The square root is like 1/2, cube root is 1/3, 4/3 would be 1/4, and all that sort of stuff. Okay, where's Clarence's song? Clarence actually never really moved today, did he? Robbie, take the derivative of this, please. Go ahead. Yeah. 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 We should probably try and neaten that up if we can. Megan, you want to try and turn that into a fraction for me, if you would? Did I have to go back to both of it? Let me try and neaten it up from here. 0?
Yeah, it ends up canceling out on the top.
Does it? Cool. Really?
Yeah.
Okay, keep going. So how do you deal with that one? This is 0?
You can sub it one. Well, you can see just from there, like if you put in 1, it's going to be like the second one's going to be 0.
Yeah. Oh, F prime. Okay, that's right. F prime of 1. Sorry, I just want to get the equation. Sorry. I forgot we actually for F prime 1. So let's go over this. So it's negative 5 times 2 minus 2x all over 3 the cube root of 2x minus x squared.
That shouldn't be equal, should it just, it should be a prime of that.
F prime X, right there.
Now, you can just go from that step if it's asking for a prime of 1. You really need to neaten it out.
How is this equal to 0 though?
Okay, I don't really like the way you're doing it because u of x should be 5 and then w
I put the 5 into the bracket.
Wait, Mr. Sadler, could you also take out a common factor of 2 from that one?
Yes, you could. But the thing is, they say the answer. Did they say the answer is 0?
Yeah, you get 0 on top. When you sub in.
That's true. But you also get 0 in the denominator, don't you?
No, you get 0 in the numerator, and then you put 0 over anything equals 0.
Right, but 0 is 0 isn't 0.
But the denominator is not 0.
Because it's minus x squared, not 2x.
5 is its own function.
No.
1.
Don't mind me. I'm not with you. Thank you. So f prime of 1 is equal to negative 5 times 2 minus 2 all over 3 times the cube root of, thank you, 2 minus 1 over 4. Thank you. Whoops. 0. Thank you. I thought we were at f prime of 0 for a second. That's what I was thinking in my head. All right.
So, can you quickly run down just the chain rule so that I understand
Yes.
fully, like what you did there?
Okay, so what I did here as far as the chain rule again was, the rule is you take the outside and the inside are 2 different things. Okay, so as far as the outside, pretend this is just something. So it's like 5x is a negative 1/3.
Yep.
Okay, so that's going to be the negative 1/3 comes down times whatever's in the middle to the negative 4/3. You okay with that?
Yep.
Then what you do is you open your hand and you take the derivative that's in the bracket. And then multiply by the derivative of what's in the bracket. That's all the chain rule is right there. Okay, 7B, that's somewhat helpful. Thank you for the class you're taking. Thank you, Nicholas, for saving me on that one. All right, here we go. Next up is 12. MCV4U? Okay, 12. Ah, yes. Okay, this is where we're starting to get to good questions here.
Is that a bad question?
No. 12 says, determine the point on the curve where y equals x squared, x cubed minus x squared.
What page is this?
This is 1. Where the tangent is horizontal.
Mr. Sadler,
Yeah.
your 12 looks like 2 beside the box.
So when tangent is horizontal, it's not being.
Just wait, not you, because everyone else, because I want to get everyone else.
Well, I don't-
This is a big concept here. If the tangent is horizontal, what does that mean? Yeah, Shannon.
0.
This means that what they're saying is, they want to know when f prime, or y prime, I guess I'll call it f prime of x equals 0. This means that your slope is 0. Okay? This is going to lead us nice into tomorrow's lesson, so I'm going to take a tangent. Right now, I'm talking about that. Okay, this leads into tomorrow's lesson, so I'm going to do this quickly. If I'm graphing a parabola, how will I be able to use calculus to find the vertex instantly? What is the slope at the vertex?
0.
The slope is 0 at the vertex. So in order to find this point, when f prime of x equals 0, you're at a local max or a local min. Okay, that will instantly give you the highest or lowest questions. That's why when John looked at the assignment, he said, Mr. Sadler, these look like grade 11 questions. They are. They're talking about the maximizing this and minimizing that. As soon as you solve f prime of x equals 0, that's going to give you a local max or a min. Okay? So in this case, if you start with a quadratic, when you take the derivative of it, what's the degree going to be then? 1. So it's going to be linear, right? So you're going to have one solution. The same thing, if I have a cubic like this, I have 2 local maxes or 2 local mins, right? And then you're going to, the derivative of a cubic is going to be a quadratic, so you have 2 solutions.
Ah,
Okay?
I was gonna say.
That's sort of what we're getting into tomorrow, okay? That's for that. Okay, that's my tangent. Okay? So this is why this question is appropriate from what you said there. For this and that's why I do this. F prime of x equals 0, the slope is 0. Okay? All right, let's get into, let's ignore this on top of this actual question. Let's do the derivative. Reed, I think we're at you. Conveniently enough. Okay, I want you to be brave, and I want you to use the product and the chain rule to take the derivative. Go ahead. I'll talk you through it. What's the derivative of x squared, please? Thank you, Reed. 2x times x cubed minus x squared. Now read. What's the derivative, please, of x cubed minus x all squared?
3x cubed. What?
What's the derivative just of this one? Squared. So let me help there. What's the derivative of the second bracket then?
Let me try.
Go ahead. Go ahead. 2 times. No? Yeah, this is still going to stick here first, right?
Oh.
Yeah.
Okay, and then 3x squared minus 1. I want to keep the same form there, right? So that's chain rule, that's what that is. Okay? Sorry, one more time?
What's the first 2x?
Okay, so what happens, I'm just, okay, can I talk, guys, please? Okay, I'm sorry. What we do is, this is a product and a chain together. Okay, so what I did was, the first thing I did was, the derivative of x squared is just 2x, your product rule, times your second function.
Oh, okay.
Okay, and then plus your first thing times the derivative of the second. I'm going to neaten this up if I can, because this is starting to get a little sloppy. 2x, x cubed minus x squared plus, what was that, 2x squared, x cubed minus x, 3x squared minus 1. Okay, there's still a lot of things we could take out here. I'm not going to FOIL it all out. Okay, but I'm going to take out some common factors. What's common between all of these guys? 2x. Anything else? So I have a 2x and an x cubed minus x. Someone other than Robbie, because I know you got this down. Thank you, Bill, for your work. What's left inside the brackets? Actually, Sam, I think up to you conveniently. If I factor out 2x and an x cubed minus x, what are we left with?
You have, x minus x.
Yeah? That's right, x cubed minus x, yeah?
Plus 2x.
Nope.
No, just
Just x?
x,
Yeah.
yeah. And then the 3x squared minus.
Yeah.
Like, do you want us to take out a common factor?
Yes, always, because eventually we're solving for 0 here, right? So in order to solve zeros, you have to have things that are factored. Okay, that's the only way to solve zeros. Okay. That's right, I know this is deep. This is a deep question. This is where the conflict's starting to get good.
I don't-
Your brain doing this right now, it should be doing this right now.
If we're solving for
That's what I
zeros
was doing.
now, I don't see how we can,
Just wait.
everything has
Just
x's in it.
wait. Just wait. We will solve zeros right now. Okay. Can somebody please, and that's Melody, neaten up this middle bracket for me if you could?
Well, that's the 2x. And then x cubed minus x
Yeah?
plus 6x cubed minus 2x.
I think there's an extra 2 in here somewhere.
Oh, I do, minus x, 1x, yeah.
Okay, so this turns into 2x, x cubed minus x. This turns into 4x cubed minus 2x. Okay. I'm going to stop right now because I'm getting too excited. Take a second and let that soak in. Okay? Please ask these questions. This is a good question. I can see this in your future, I guarantee. Okay? All right? So please put a star on the heart beside this question because this is the first one that we've seen in this unit and I'm loving. Well, other than that one with the A's, the B's, and the C's, and the D's. Okay, remember that one earlier on? Yes.
Okay, if we're subbing in 0,
No, we're not subbing in 0.
we're setting it equal to 0?
Yes. Okay.
That makes sense.
Now, we're not done with the factoring. Can I get somebody named Shannon who's brave? Is there any other factors we can take out there?
Take out an x.
An x from here, right? And an x from here, I think. Probably 2x from here, right? And an x from here. Is that right? So that's going to change this to 4x cubed, x squared minus 1, and 2x squared minus 1. Is that right? Yeah. Okay. Now I'm going to put down my electronic marker for a second. This is where the aha moment has to come in. I got to solve my proofs. I can still factor. I can still factor twice, in fact. Sarah, be brave. Factor one of those brackets for me, please.
Do difference of squares.
Yes, difference of squares. Okay. So this turns into x plus 1, x minus 1. Okay, and we're going to factor again. What's this? How do you factor 2x squared minus 1?
How'd you get
Oh, sorry.
how'd you get 4x cubed?
Yeah, so sorry, what I did was I took an x from here and an x from here,
Oh,
so and then I divided this one by 2. Yes.
I'm feeling crazy. What if you did root 2x plus 1? Root 2x minus 1.
Now you're saying, why is that all, why do I have to do all that? The question was. Okay? I go to the same page, I
Because
can.
we just now found the maximums and minimums.
Well, we did, but we looked for a 1 equal to 0. So really what we all wanted to solve, we really wanted to solve this equation. And that stops there. Remember, the thing about factoring is it makes your roots so easy. Now, you didn't need to do that. You could have like done it from here if you really wanted to, right? But this allowed you to find the roots. You can find these instantly. Did you ever think, Courtney, when you first learned about roots all the way back in grade 10, you would ever have such an awesome question? Probably not. Just go with it. You know, okay? Alright, good. Okay, so what does x equal then? What are my possible values for x? Yes.
0.
Good. So this tells me that x equals 0, right?
Can I name them all?
Yeah, this turns into you going, John.
Oh, sweet. That's going to be -1.
Yeah.
Then +1.
Yeah.
Is it going to be root 2? 1 over root 2? -1 over root 2? Oh, that's cool. That's going to be +1 over root 2.
That is cool.
No, yeah.
So is this what Albert meant last semester when he was freaking out all the time saying, oh, this will be so much easier with calculus?
Yes. When you get to graphing next unit, you're going to say, oh, Mr. Sadler, why didn't Mr. Lacy show me this 3 months ago? Okay. Or why didn't Mr. Kemp show me this a year and 3 months ago?
But it's just, when I got my common factor,
Yeah.
after I did the 3x cubed,
Yes.
I just did it all from there.
Yeah. From where? Sorry, from here.
Yeah.
From here. Yeah, that's fine. But the problem is because of zeros, like it's going to get messy, right? So, as long as you get these answers at the end, I don't care how you do it. For me, factoring works best. That's why I'm a math teacher. Okay. If you've saved yourself, Mr. Sadler, I would never see that this is a difference of squares. How to do it. That's okay. What you can do is
Well, I did it twice.
just solve 2x squared minus 1 equals 0. So 2x squared equals 1, x squared equals 1/2, x equals plus or minus 1 over root 2. That'll work too. Okay. Ooh! Point what?
0.7071.
Ah! Take it back, Reed. You're hurting me right now. Take it back. You're going to hate
It's for
trade.
imaginary roots, too.
You're going to, I'm sure there are lots of imaginary roots, okay? Oh, dude, if my heart stops today, it's because we just said 0.7071 instead of 1 over root 2. Okay, oh, I shouldn't make that joke with my wife. Okay, I shouldn't make that joke again. Okay, we're all good on this and kind of keep moving? Did that help? Did that help, Caitlin?
That made me feel great.
It should. This should give you a warm, fuzzy feeling. Like, calculus is nice when it works out. That's the thing. When it doesn't work out, that's, yeah, okay, but this is good for now. I'm going to stop in the video. You guys can talk amongst yourselves for 60 seconds. Then we'll move on to the next question.